Assalamu alaikum everyone. Let's just jump right into today's explainer. We're doing a tafsili wazahat, a really detailed deep dive into something absolutely fundamental in math, the highest common factor. If you've ever looked at a bunch of numbers and wondered exactly how they perfectly interlock, well, you're in the right place. Let's get right into it.
Real quick, here's our roadmap. We'll cover what the HCF actually is, then we'll look at the prime factorization method, how to find those common factors, the common division method, and finally, we'll wrap up with some important rules and a quick summary.
Okay, let's dive into this. Section 1. What is the HFC?
So, the highest common factor. By definition, it's the absolute largest number that can exactly divide two or more numbers. And I really want to emphasize that word exactly here. We're talking about the biggest possible number that goes into multiple numbers without leaving any fraction or remainder behind. None. It goes in perfectly. It's kind of like the ultimate shared building block.
All right, moving on to section 2, the prime factorization method.
So what does that actually mean? Well, prime factorization is simply the act of breaking a number down into the multiplication of its prime factors. Think of it like taking a big, complex Lego building and dismantling it back into its most basic fundamental bricks. You just keep breaking a large number down until you're left with nothing but a sequence of purely prime numbers all multiplying together. Let's walk through an example step by step to make this a bit more concrete. Let's take the number 60. We start by pulling out a prime number, let's say 2, which leaves us with 2 times 30. Then, we pull another 2 out of that 30, giving us 2 times 15. And then, we just take that 15 and break it down into 3 times 5. And just like that, boom, 60 is perfectly factorized as 2 times 2 times 3 times 5.
Now let's try this with a much larger number, 192. We pull out a 2, leaving 96, another 2 leaves 48, a third 2 leaves 24, a fourth 2 leaves 12, a fifth 2 gives us 6, and a sixth 2 leaves us with exactly 3. That is quite a sequence. 192 breaks all the way down to its prime components, 6 2s and a single 3, all multiplied together.
Now, what's really interesting about this is how we transition. Section 3, finding the common factors.
So we line up our prime factors for 60 on the top row and the prime factors for 192 on the bottom row. What we're doing here is looking for the exact matches across both rows. Notice those highlighted numbers? It's a great visual aha moment. You can see 2 2s and a single 3 aligning perfectly across both the top and the bottom.
So, what do we do next? We extract those glowing, perfectly matching common factors. Our shared numbers are 2, 2, and 3. We pull them out so we can prep them for our final operation.
And that operation is just simple multiplication. We're going to multiply these common factors step by step to reach our final answer. Take that first 2, multiply it by the second 2 to get 4. Then multiply that 4 by our 3.
And we get 12. The highest common factor of 60 and 192 is exactly 12. That literally means 12 is the absolute largest number in existence that can perfectly divide both 60 and 192 with zero remainder left over. No fraction, nothing. Just clean division.
But hey, what if you prefer a slightly different approach? Section 4, the common division method.
In this method, instead of breaking the numbers down completely separately, we actually place 60 and 192 side by side, and we divide them simultaneously. So, we divide both by 2 to get 30 and 96. We divide them simultaneously by 2 again, to get 15 and 48. Then we divide them both by 3, which leaves us with 5 and 16. Now, at this point, 5 and 16 share absolutely no common factors, so we stop dividing right here.
Now look over at the left side of our division setup. What numbers do we divide them by? Well, we used a 2, another 2, and a 3. And just like with the first method, we extract those common divisors on the left side, and we get ready to multiply them.
And this brilliantly illustrates how math is just wonderfully consistent. Multiply 2 times 3, and we once again get 12. Both distinct methods, prime factorization and common division, give us the exact same undeniable proof that the highest common factor is 12. Let's lock this in with a second, slightly bigger example, just to make absolutely sure you've got the hang of it. This time, we'll use 3 numbers, 425, 200, and 100. We place them all together. All 3 can be simultaneously divided by 5, leaving us with 85, 40, and 20. We divide by 5 one more time, leaving 17, 8, and 4.
And right there, we hit a wall. There are absolutely no common factors left that can divide 17, 8, and 4 at the exact same time.
So once again, look to the left. We simply grab the shared divisors we just used for this new, larger set of numbers. Our common divisors are 5 and another 5. Now you know the drill. Multiply them together.
Bilkul sahi. We reveal our final result, 25. The largest single number that can perfectly divide 425, 200, and 100 is indeed 25. Honestly, it really is that straightforward once you break it down visually.
Which brings us to Section 5, Important Rules and Summary. So, the crucial point here is that you can always find the HCF successfully if you just follow this definitive chronological path. Step 1, find the prime factors of your numbers. Step 2, identify the exact common factors they share. Step 3, multiply those common factors together. And Step 4, that resulting number, that's your highest common factor.
So आज हमने सीखा, what did we actually learn today? Well, HCF stands for highest common factor, and it simply represents the greatest common divisor between any set of numbers. And as we proved today, both the prime factorization and the common division methods work perfectly to find it.
Bye students. Don't forget to subscribe for more fun math videos.